Hi, I'm Katie.
And I'm AJ, and our project was on rain gauges. We will talk about rain gauges and how they work, sources of error, calibration, and some variations of other types of rain gauges.
A rain gauge is a container that catches rain or precipitation. It measures the amount of precipitation that falls during a given time interval at a certain location. This is useful for flood forecasters, meteorologists, and farmers. It can show fluctuations from year to year, help farmers plan when to plant so that they have successful harvests. Volunteers measure and record data and send it in to the Community Collaborative Rain, Hail, and Snow Network, who analyzes it and applies it to water resource analysis to help with things like storm warnings.
Rain gauge works by collecting precipitation in a funnel, and the water flows from the funnel to a graduated cylinder. The rain can be measured by reading the height of the rain gauge in the graduated cylinder. Even though rain is collected in volume, it is measured in inches or centimeters. Each gauge is calibrated to read a height, which is done by dividing the volume of the water by the area of the opening of the gauge. If the rainfall is more than what the measuring graduated cylinder allows, the water will flow into an overflow cylinder. To read the amount of water in the overflow cylinder, the water in the measuring device must first be poured out.
The sensor of a rain gauge is the funnel. This is because it is the first piece of the rain gauge that the rain comes in contact with. The transducer is the stem because the volume of rain collected is shown as a height change. The signal conditioning is also the stem because the smaller the diameter of the inner cylinder, the more precise your measurement will be. The output is the tick mark scale that the height is read from on the outside of the rain gauge. Some sources of error are strong winds during storms. The turbulence caused around the gauge can be lessened by using a more aerodynamic gauge shape. These are more expensive, but will give more accurate readings. Another source of error is trees and nests. Trees can be avoided by placing the gauge in an open area. Nests can be avoided by putting mesh over the opening of the gauge to avoid animals nesting inside of it. You must be careful with sprinklers because their water can affect your rain gauge measurements. You also need to watch out for water evaporation. You can use gauge oil to trap the water in so that it's unable to evaporate. Dew should not be reported as rainfall measurements. Rain gauges are also subject to zero drift, just like rulers have a 0 point. You have to make sure that you know how to read your device because they're all a little different.
The quality of measurement is determined by the errors which were mentioned in the previous slide, and the resolution of the rain gauge's inner graduated cylinder. For most rain gauges, the measurement has an accuracy of 1/100th of an inch, but that can change between the various types of gauges.
The calibration of a rain gauge is based on measuring the water's volume and then determining the water's mass. It is known that 1 milliliter of water weighs 1 gram. To calibrate a rain gauge, place the gauge on a tiered balance. Record its mass. Partially fill the gauge with water and read its volume. Record the new combined mass of the gauge and water. Subtract the gauge mass from the combined mass. Then, plot a calibration curve of the volume read and the mass measured.
Besides the traditional rain gauge, which needs to be read by human eyes, there are additional rain gauges which can be determined digitally. One of the digital rain gauges is the tipping bucket gauge. This gauge works by collecting precipitation in a funnel, just like the traditional gauge, but then the rain flows onto the tipping mechanism. Once a predetermined amount of rain flows onto the tipping mechanism, it will switch or tip towards the second bucket. The gauge counts how many of these switches occur, and that is how it measures the amount of precipitation. This kind of rain gauge also has its sources of error. A large enough gust of wind can cause a switch, and if rainfall stops mid-switch, that amount of water is not accounted for. Also, the funnel can overflow if rainfall is heavy enough. A weighing gauge is another type of rain gauge. Instead of measuring the volume of the rain, this gauge measures the amount of mass of precipitation. An advantage to this type of rain gauge is that it can also measure solid precipitation such as snow or hail.